Would you know a broken pen if you saw one? And does an earthing system like a TNS make any difference? In this video, we're going to be finding out if electric vehicle chargers need O-pen protection on a TNS system. But before we answer that question, let's remind ourselves of some of the terms we'll be using and what they mean, starting with a TNS and a TNCS. TNCS stands for Terra Neutral Combined and Separated. What this means that in certain parts of the system, the neutral and earth conductors are combined and then separated for the final distribution to the premises. One of the reasons this is done is because it's cheaper, as we're only running two conductors from the substation, the line conductor and the combined neutral earth conductor. This is what we call the pen conductor, short for protective earth and neutral. As the system branches out to individual buildings, such as your home, it splits into separate earth and neutral conductors. This separation is crucial for safety because it ensures that any fault can safely flow to earth without carrying a risk of running through the neutral. The TNCS system provides an efficient, effective way to protect homes and installations from electrical faults, maintaining safety whilst being cost-effective for distribution networks. The TNS system is a Terra Neutral Separate system, which has three distinct conductors: line, neutral and earth. This is an excellent system as fault currents can be distributed down a separate conductor to earth. However, with running in an additional conductor, this will increase the cost of the distribution cable. But what is a broken pen? Okay, so let's take this row of houses, all being fed from the substation at the bottom of the street. Each property takes its line and neutral from the supply cable from the road outside. As we can see, the neutral is taken from our start point of the transformer, which is earthed with these rods. This provides the potential difference and makes everything work. This also creates the protective earth and neutral or pen conductor. Right, let's break this pen and see what happens. In house 1, which is before the broken pen, things are fine. Power is flowing and there is basic protection via an earth connection back to the earthing conductor. However, in house 2 and 3, the neutral is broken, but everything is still working. How is this? Well, this is because our neutral and earth are combined, and they are combined here at the main earthing terminal, or MET. Also at the MET, we have connected a bonding conductor to the water, which has a referenced earth voltage of 0 volts. This means that even though the neutral in the road is broken, we still have a potential difference between line and neutral in the property. As current is flowing through the line, it returns via the neutral, or at least it would if the neutral was there. This means that a potentially dangerous potential could rise in any metalwork that is connected to the MET, which could include an electric car. This dangerous rise in potential could be discharged through a person if they were stood on the literal earth, as a difference exists. This is why pen fault protection is really important in car chargers. But this problem only exists with a TNCS due to the combined nature of the earth and neutral, but not in the TNS system, which brings us back to our question: do we need to fit pen protection on a TNS?
We can see here that if an open circuit on the neutral was to occur, then everything in the installation would stop working, as the neutral and earth are separate. Well, the code of practice for electric vehicle charging equipment says that if the system is TNS, we can rely on the earthing method as long as we have it guaranteed that the separate earth goes back to the supply transformer.
So how are we going to be able to guarantee that?
Well, most of the time you can't, and this is because it's common practice to convert older TNS systems into TNCS, and not just at the supply intake. So why are incoming supplies changed to a TNCS PME system? A DNO may upgrade a TNS system to a protective multiple earthing system as part of electricity supply repairs. This typically occurs when service cables and joints on paper insulated lead covered cables or PILT fail underground. To address these issues, DNOs often connect the supply neutral to an earth electrode using combined neutral and earth cables. Over time, this process can result in some DNO networks transitioning to a TNCS and PME system. It can happen underground. In fact, it would be very difficult to determine exactly what the earthing arrangement is due to the amount of work which the DNO has conducted on its network. This is why the code of practice states that unless we can guarantee that the supply is TNS and comes from its own transformer, we have to treat it as a TNCS. and this means ensuring we provide protection for broken pens.
Now, this normally takes the shape of open pen protection, which is fitted as standard to most EV chargers.
Things get more interesting as well when we look at feeder pillars like this one made by Lewden and the earthing arrangements required, and I'll be going into more detail in a later video.
And if you just can't wait for that video to land, then you can head over to the know-how page at efix.co.uk, where I've done a full suite of videos on this very subject, and get a certificate to prove you've completed the course, which counts towards your CPD. But from me, it's bye-bye for now.